we will go over the lymph where it's originated, but for now, how to divide into its components. The lymphatic organs itself consist of the spleen, which is the largest organ, the thymus gland, the lymph nodes. Sometimes in some anatomy or physiology books, maybe they separate the tonsils or separate the lymph nodes from the lymphatic organs, but overall they are considered part of the lymphatic organs also. And also the tonsils. Following me? Now, the spleen located on the left upper abdominal quadrant, the thymus gland inside the mediastinum, the lymph nodes, they are distributed all over the body, and they are clustered especially at the area of the groin or inguinal region. Groin or inguinal means groin, okay, inguinal region, lumbar, including the abdominal region, thoracic, axillary region or armpit, neck area. In the neck, we have superficial and deep lymph nodes. All right. Also in front of the ear, interior auricular, and back of your ear called the posterior auricular lymph nodes. The tonsils, we have 3 pairs of them. One pair of them, or they are just in the back of your mouth or oral cavity, just on each side of the uvula, called palatine tonsils. One pair behind the nose, they are called adenoids. They are called also pharyngeal tonsils. And one pair behind your or underneath your tongue called lingual tonsils. All right. So far so good. That's the general organization of the lymphatics, and we can go over every single part of this also. Got it? Okay. Now, what is lymph? It's
what is lymph?
yeah.
Oh,
Okay. I explain it. I explain it.
Okay.
We have the all right.
Oh, sorry.
You know that we have the blood circulation, right? Arterial blood circulation. It starts from the heart to the aorta, and then arteries, and then smaller arteries, arterioles. Eventually, we have the capillaries, right?
Yes.
Capillary network surrounding all our cells and tissues, right?
Yes.
The capillaries, blood capillaries, all right, they they carry the blood, which is oxygenated or blood with oxygen. Now, plus they carry the food or nutrients and also hormones and many other stuff for your cells and tissues. to supply inside any organ. Following me? All right. Plasma, in order to supply oxygen by diffusion, gets into your cells and tissues by the diffusion mechanism. So gases, they can pass by diffusion from higher concentration to lower concentration. So from the capillaries or through your blood circulation carries the oxygen to the 97% through the hemoglobin, and then as soon reaching the capillaries, oxygen separates from hemoglobin and then gets into your cells and tissues, because inside the cells you have less oxygen, but you have more carbon dioxide as a waste. So oxygen can diffuse to your cells and tissues. But the rest of the materials, such as hormones and nutrients, they are carried by the plasma. So plasma leaks from your blood capillaries into the space of cells and tissues. Cells inside our organs, they are not tied to each other. Follow me? But they are not tied like mosaic tiles. You will see very small water space between the cells inside in all tissues and organs. That space is called inter. Inter means between in medical terminology. Interstitial. Interstitial means a space. Interstitial space. So plasma leaks into the space of interstitial space. Follow me?
Yes.
All right. Supplying all the nutrients to your cells and tissues inside the organs, but it returns back to the blood circulation. Following me? Okay.
So plasma goes into, it leaks into the interstitial space, and then from there, it does its function.
After supplying nutrients and everything, it returns back to the blood circulation.
Okay.
Okay. So
how does it get back to the blood circulation?
very good. Okay. So the other end of the capillaries, okay, other end of the capillaries, now as soon as applying oxygen to your cells and tissues, deoxygenated blood, all right, deoxygenated blood, which is called venous blood, carries carbon dioxide or CO2 back to your blood. How it's returning back to the blood circulation, I tell you the mechanism of that also. So getting into the blood capillaries, and from capillaries to the venous, all right, to the venules, and then to the larger veins, gets back to the heart. And what's the mechanism how the plasma is returning back to the blood? Because inside our blood capillaries and blood vessels we have a very important protein, plasma protein called albumin. That albumin or plasma protein produces a pressure. That pressure is called osmotic pressure. So it applies a pressure on the plasma, which is soaking back the plasma into what? Back into the blood circulation. So plasma returns back. And that albumin plasma protein never ever leaves your blood circulation unless what? Kidney disorder, okay, all right, glomerulonephritis or any other situation. Got it? So that's under that mechanism of osmosis or osmotic pressure, plasma protein applies pressure on the plasma to take it back. Otherwise, we would have a bag of fluid within a day
And
or
that's
two.
edema.
Or developing edema.
Okay.
That's right. Okay.
Makes sense.
Okay, you're right.
All right.
You got it?
Okay.
Okay.
Now, the question is this: the entire 100% of plasma returns back to the blood circulation? No. How much returns? I can tell you 99% of the plasma returns back to the blood circulation, into the end of the capillaries, and from the end of the capillaries. So it picks up the carbon dioxide, so venous blood circulation returns back to the blood, And that's the mechanism how it returns, 99%. Under the osmotic pressure, under the pressure which is applied by the plasma protein called albumin. In fact, the albumin is a very important protein which maintains your blood volume and blood pressure. If you have kidney disorder, glomerulonephritis, or any other disorder, plasma protein can leak into the interstitial space and then it shows in the urine also, and then that blood pressure drops, blood volume drops, edema swelling can develop.
Okay, and this doesn't have anything to do with this right now, but if you have time, can you explain bilirubin?
Okay.
Because I know that it attaches, and I don't understand that, but I mean, I don't want to get off track right now.
Okay.
If it doesn't work in.
All right.
I don't understand bilirubin.
Okay.
Is that okay?
That's fine.
Okay.
All right.
Okay.
For bilirubin,
We need to know.
you need to know where it's coming from.
Liver.
The bilirubin, the red blood cells, they have only life of 120 days or 4 months because they don't have a nucleus. So after 120 days or 4 months, they get into an abnormal shape called crescent shape. So they are dysfunctioning. The hemoglobin inside those abnormal crescent-shaped cells cannot carry oxygen and carbon dioxide for you. So when they get, after 4 months, they get this abnormal shape and they pass through the spleen. The spleen and mostly spleen. Liver also can do this function. The spleen is going to recognize that. How? The spleen has its channels. The channels are just only feasible for normal red blood cells or erythrocytes to pass.